So this is going to be a video of the second day homework to help you. I'm not going to do all of them. Some of them are actually a repeated problem from the day before. So I'm going to pick and choose, but it should help you, especially over the weekend, since we have new teachers for the new semester on Monday. For 1G, I'm going to factor out a sign because these both share a sine x. And when I do that, I notice that I have my first Pythagorean identity. So this is sine x times 1, which is just sine of x. All right, let's see, which one am I going to do next? Number 3 on page, this is page 13. Rewrite it so it's not a fraction. So the strategy for that is to multiply by the conjugate of the denominator. This is a plus, so we have a minus. So now when we multiply the denominators, we're going to get 1 times 1, 1 times negative sine, sine times positive 1, and then sine times negative sine is negative sine squared. There's my numerator. Because they're conjugates, those middle terms eliminate to 0. And we have 1 minus sine x over 1 minus sine squared. Well, 1 minus sine squared is one of our Pythagorean identities. So I'm going to keep modifying. So here's the Pythagorean identity. If I subtract sine squared to the right, I'm left with cosine squared. So this is 1 minus sine of x over cosine squared. But that's still a fraction, and I want no fractions. So I'm going to think of this as 1 minus sine of x times 1 over cosine squared. So what is the reciprocal of cosine? That is secant. So now here is my final answer with no fractions. Okay, 4. We want to add and subtract these together. I'm just going to do C because that's the craziest one. So here we go for C. I'm going to start here because this looks insane. So secant of negative theta. If you look back at the beginning of your packet, we have some odd even identities. So secant of negative theta is the same thing as secant. That is because it's based off of the cosine graph. So we get this even symmetry. So this y value is the same as this y value, even though one's at negative theta here and this one's at positive theta here. So this becomes cosine squared theta plus secant theta plus, I don't like this, so the reciprocal of cosecant is sine. Oh, look what I see. That's going to be good. I'm going to leave this alone for now. So cosine squared plus sine squared is 1. And then, well, let's deal with this. We need a common denominator of cosine. So I'm going to turn 1 into cosine divided by cosine. And I'm going to put that over 1 just so that it looks good. All right, what else can I do? What else can I do? Nothing squared. But you know what? Secant is the reciprocal of cosine. So when I multiply this numerators together, watch this. I'm going to do 1 times 1, 1 times secant, negative cosine times 1, negative cosine times secant. And just looking here, where's some scrap paper? Cosine theta times secant theta. Well, secant is 1 over cosine. So that reduces to just 1. So now this is just 1. So I have 1 minus 1 is 0. My numerator is secant minus cosine. So let me keep going. Secant minus cosine all over cosine. And then instead of doing all over cosine, I'm going to make this secant divided by cosine minus cosine divided by cosine. I'm just going to go backwards from a common denominator. This is 1. This term, now I run out of space, is secant times 1 over cosine. Now minus 1. Well, 1 over cosine is secant. Secant times secant is secant squared. Finally at the end here. All right, check this out. From our Pythagorean identities, you can't see that. Secant squared equals 1 plus tangent squared. So let me write that off on the side. Secant squared equals 1 plus tangent squared. So I can manipulate this to get secant squared minus 1 if I subtract 1 to the left. So this equals tangent squared theta. So the answer to C on page 13 is tangent squared theta. That's a crazy problem. Wow. All right, one more page, 14. Write each one in factor form. Oh, I like factoring. Factoring is forever, says the Algebra 2 teacher, also teaching pre-calculus. Okay, I'm gonna think of this as w squared minus 4w plus 3, and we had one of these on yesterday's homework, so no, I'm not. Let's do C. We have a quadratic where a is not 1. The two strategies we taught you in Algebra 2 was either box method factoring or split the middle factoring. I'm going to do box method. So 2 times negative 3 is negative 6. All the ways to multiply to 6 are 1 and 6 and 2 and 3. We have to add to negative 1. So that's going to be 2 and negative 3. So here's how box method works. If I have enough time, I'll show you split the middle so you can pick your favorite. Oh, I should have enough time. Okay, so since this is negative w, I'm going to write these as 2w and negative 3w. It does not matter what diagonals you put these in. This 2w squared is the first box, and this negative 3 is the second box, the last box. So now it's a puzzle. I need to put my terms on the outside so that when they multiply together, we get these boxes. So negative 3 has to be 1 and 3. That's the only way to do that. But I can't put the 3 up here because of this 2. So the 3 will go here and the 1 will go here. And this one has to be negative since this row is negative. So now to make a 2w, this has to be 2w. So to get 2w squared, this has to be w, and let's check. Is w times negative 3 this? It is. So our factors are w plus 1 and 2w minus 3. Well, we started with cosine. So really it's cosine theta plus 1 and 2 cosine theta minus 3. All right, split the middle. Here's how it works. I'm going to do the same process with this negative 6. But now instead of writing it in the box, I'm going to write 2w squared plus 2w minus 3w minus 3. So I took this negative and I split it to those terms. Then I'm going to look at the first half and the second half and factor the greatest common factor. So these first two terms share a 2w. I factor it out. These two terms share a negative 3. This only works if these brackets are the same. They are, so now I can regroup it. 2w minus 3, the coefficients become one factor, and the matching becomes the other factor. Just one time, and we get the same factoring. All right, let's do D, because why not? we have cotangent cosine squared minus cotangent. So the factoring here is the greatest common factor of cotangent. So I'm going to factor that out. And then cosine squared x minus 1 is from my identities, from good old Pythagorean identity. But I have to do a little more work. Sine squared plus cosine squared equals 1. I need cosine squared minus 1, so I'm going to subtract 1 to the left. This is what I want to keep, so I'm going to subtract sine squared to the right. So cosine squared x minus 1 is negative sine squared, so I can replace this with negative sine squared. And since it's all multiplied, I'm going to say negative cotangent x sine squared x. Oh, no, I'm going to keep going, because guess what? Cotangent is cosine over sine times sine squared. So one of these can eliminate this one. So our final answer, that was exciting, is negative cosine x sine x. Oh, squeezed in the bottom. Because this is sine times sine. So one of them can eliminate with the denominator. If you are still stuck on your homework this weekend, call a friend. There are 8 or 9 sections of pre-calculus. Plus the honors pre-calculus classes are doing the same thing. Get help. Do not leave it until the last minute. We have a quiz coming up.